Yeah. So good morning, all. So today, good morning, all. This is Professor Ashish Malgave. Wants to discuss regarding the power quality subject. So in power quality, right now we are discussing about long duration voltage variations. So as you know, so power quality issues, there are n number of power quality issues such as voltage sag, voltage swell, interruption, transients, sub-transients, short duration voltage variations, and long duration voltage variations. Now we are going to deal with this long duration voltage variations, and so what is going to happen if these long duration voltage variations are there with the system, and how that long duration voltage variations are hamper the power system that we are going to deal with in this chapter. See, so first point that we are going to discuss, that is principles of regulating the voltage. Now, why we need the voltage, or why we have to keep the voltage as regulating? That means, so we want a constant voltage. Now, so if you are going to think about the root cause, so high impedance in the power system leads to an inadequate voltage supply to the load. Many times, so we are having the load that is connected to the power system. That load is having high impedance. Because of that high impedance, there may be a chances of inadequate voltage supply, or you will get what you can say less voltage to the load. Now why this is going to happen, and what is the reason behind that? If you are going to think about the root cause, so heavy load, voltage drop due to high impedance, and light load, so boosting source voltage can cause a over voltage condition. So in both case, if you are going to consider, so in the both case, if the impedance, if you are going to keep high, and if the impedance, if you are going to keep low, so high impedance, that means more load, and heavy load is there, then you will get a voltage drop. And comparing that with the light load, that means less load is there. In that case, you will get a over voltage condition, and that over voltage condition plays a because of that you will get the over voltage. That means in simple words that we can say, that is what the voltage swell. So that means continuously deregulation of the voltage is there, so regulating voltage is not there. Now what are the corrective measures that we can take to regulate the voltage? So what are the different things that we need to add, need to incorporate, so that you can make that voltage as a regulating one? So first thing that we are going to discuss is here, that is compensating for impedance Z. That means we have to use the compensator, or we have to think about the impedance, how much maximum load that will be there. So all these points, and we are going to compensate this impedance. So compensating for the voltage drop caused by the impedance. Again, so how we are going to compensate the voltage drop that is caused by the impedance? So we are going to think in that way. The core issue is that a weak power system struggles to regulate the voltage properly under varying load conditions. See, so everywhere many times the load is varying. So if you are going to think about, if you are going to categorize the power system in two different categories, a weak power system and good power system or best power system. So on which basis that we are going to tell like this is what the weak power system? If you are going to think about the weak power system, you will get what you can say, you will you will get a struggles to regulate the voltage properly and under the varying load conditions. Now some common options for improving the power system voltage regulation. Now again, if you keep in mind, so what is the meaning of voltage regulation, and what is the ideal value of voltage regulation, and what are the different precautions that we need to take, so that we have to regulate the voltage, or we have to improve the voltage regulation. So simply, so first of all, we are going to deal with the voltage regulation. So change in terminal voltage from no load to full load, divide by no load, multiply by 100, you will get a percentage regulation. So ideally, what is our requirement? Our requirement is, so whatever the load that you are going to connect to the power system, that load and if you are going to change or varying load, if you are going to connect, then voltage that should be a constant one. That is what the ideal case, but that is not going to happen. So what is going to happen if the impedance is more? So ultimately you will get a voltage drop. Otherwise, second thing, if the less impedance is there, then you will get over voltages produced in that. So, so what are the things that we are going to use to improve the power quality or power system voltage regulation? The first one, that is add shunt capacitors to reduce the current I and shift it to a more in phase with the voltage. So first thing that we have to do, that is adding shunt capacitors. So if you are going to add the shunt capacitor with the circuit where we are going to connect the load, then because of that you will get improvement in the what you can say angle between voltage and current. And if the improvement is there, then definitely you will get the voltage regulation there, or you can improve that voltage regulation if you are going to connect the inductive load. This is very important. If you are going to connect the inductive load, that means more inductive load is there, so in that case you will get a lagging power factor. Now to improve that voltage regulation, we need to add capacitor in parallel with that particular circuit. And if you are going to add that capacitor in parallel with the circuit, so definitely we are going to improve the voltage regulation. Second thing, add voltage regulators which boost the apparent power or apparent voltage. So we have to add the voltage regulators. Either if you are going to think about the OLTCs, that is on load tap changers, off load tap changers. If you are going to add these OLTCs, OFTCs or some different kinds of voltage regulators, so if you are going to add that, then definitely we are going to improve the voltage regulation of the power system. Then third thing that we are going to discuss here, that is reconductor lines to a larger size to reduce the impedance. This is what the another third method that we can use to improve the voltage regulation of the power system. Now, what are the different devices that we can use for the voltage regulation? So we can use either tap changing transformers. So this is that we have discussed earlier. So OLTC, that is on load tap changers. Otherwise, we are going to use the off load tap changers. So if you are going to use on load tap changers, that is better, because so as soon as your voltage is going to drop, that can be sensed by that particular OLTC, and accordingly to the tapping actions or accordingly the tap of the particular transformer that is chosen by that particular OLTC, and you will get a voltage regulation in a proper way. So this is what the good method, that is what the tap changing transformers. Either you are going for off load, otherwise we are going for on load. On load, that means automatically you will get the tap changing. But if you are going to think about the off load, then we have to stop all the system, then we have to improve that, and then that means that is what a manual system is there. So that is time consuming. So that's why, so off load time changer, instead of that we have to go for on load tap changer. Now next thing that we are going to discuss, that is isolation devices which separate the voltage regulators. Now the isolation devices, so such type of devices that we are going to incorporate in the power system, so that we are going to separate the voltage regulation or regulators. This is also another method, that device that we can use for the improvement of the voltage regulation. Next thing, that is impedance compensation devices such as capacitors. Simply, so most type of load that is inductive in nature, so that's why to improve the voltage regulation of the power system, you need to add capacitors are in parallel with that, so that you will get improvement in the devices or improvement in the voltage regulation if you are going to use such type of devices. So ultimately, voltage regulation and the load that is connected to the power system. So which type of load is there, how much is the rating, how much is the maximum capacity of the load, and how much current that is taken by that particular load, so from the power system. So depending upon that, you will get the voltage drops. So this side or this slide deals with the devices for the voltage regulation. Now voltage regulation solutions and its devices. Now, what are the voltage regulation solutions? So first one, that is tap changing transformers. That means either we have to go for the offload, and otherwise we have to go for the electronic one, that means automated one, that is OLTCs. Now what type of designs are there? So oftenly that is what one type of auto transformers, but also usually in 2 or 3 winding transformers also. Then we are going to think about the isolation devices. So isolation devices such as UPS system, so ferro resonant transformers, motor generator sets. So these devices that also that we can use for the voltage regulation or for the improvement of the voltage regulation. And these are the expensive. See, if you are going to think about the isolation devices such as UPS, that is uninterruptible power supply. So ferroresonant transformers. So these are the transformers that we can use to isolate the devices. Motor generator side. That is also that we are going to use for the isolation device for the voltage regulation purpose. So all these devices are having more expensive. So that's why what you can say, you may get some harmonic distortion in the power system. Again, that is the part of power quality where you will get the harmonics. That means power quality issues such as harmonic distortion that you are getting there. The next point that we are going to discuss, that is what the shunt capacitors. We can use the shunt capacitor to maintain the voltage constant one. So can we switch to follow the load or fix to avoid the under voltage conditions? So this is what the one way that we are going to use the shunt capacitor to maintain the voltage constant. Then we can use the series capacitor also. This is what the use rare in utility system but effective for large and fluctuating loads. For example, rock crushers. So if you are going to think about the rock crusher, where we are going to use a series capacitors to improve power voltage regulation. Now effectiveness, best in system with a high inductance, less effective in resistive system. So again, the effectiveness that is given. So if the high inductance is there, then we can use this series capacitor. But if the more resistive load is there, then we are not going to use, because you will get a less effective. That means efficiency goes down. So this is what the way that devices that we are going to use for the voltage regulation purpose. Now the static war compensators. Again, this is what the fax device. So fax device means what? That is flexible AC transmission system. So rapidly control on the reactive power to stabilize the voltage. Now here applications used in arc furnaces. So we can use that in the stone crushers or load causing voltage flickers. So in a different devices that we are going to use this or these devices that we can use for the voltage regulation purpose. Now next point or next slide that we are going to discuss about the utility step voltage regulators. Now utility step voltage regulators. So regulation range, typically regulators adjust the voltage from -10 to +10% in 32 steps of 5 by 8% or 5 to 8%. Type of installation, three-phase load tap changers used in distribution substations, single phase regulator common on feeder, often installed in banks of 3 or 3-phase feeders. Then we can use the open delta regulator bank, cost effective option for lightly loaded feeders requiring only 2 regulators. So operations, step voltage regulator uses tap changing auto transformers to adjust the voltage. Speed, the regulators are slow with a delay of 15 to 45 seconds. So application, ideal for slow voltage variations over minutes or hourly, typically on long feeders. So voltage control regulates the voltage within the band of 1.5 to 3 volt on 120 volt base. So line drop compensator helps prevent the over voltage near the regulator by stabilizing voltage further downline. So this is what the step voltage regulators or utility step voltage regulators. Now here there is diagram. So this diagram is regarding schematic diagram of one type of utility voltage regulator, so commonly applied on the distribution lines. So this is utility voltage regulator. So that is at the distribution level. Again, so we are going to connect that to the series winding, then bridging reactor is there, and source side and load side is there. That means so we can choose a particular tap so that you can get a proper voltage at the load side. So process is same as that of OLTC, that is on load tap changer, or OFTCs. So we are going to choose the different taps so that you will get a voltage regulation in a proper manner. Now electronic tap switching regulators. So electronic tap switching regulators can also be used to regulate voltage. They are more efficient than ferroresonant transformers and use SCRs on or triacs to quickly change the taps, and hence voltage. So tap switching regulators have very fast response time of a half cycle and are popular for medium power applications. So this is what the OLTC, this is what the perfect example of OLTC, that is on load tap changer. Then we are going to discuss that is magnetic synthesizers. So in magnetic synthesizers, although intended for a short duration voltage sags, that already we have discussed, so can also be used for steady state voltage regulation. One manufacturer, for example, states that for the input voltage plus minus 40%, the output voltage will remain within plus minus 5% at full load. So this is what another one device that we can use for the voltage regulation, that is called as the magnetic synthesizer. And so this is the device that can be used, so where you will get input voltage up to 40% but output voltage within the limit, that is plus minus 5%. That much of voltage changes that is permissible as per as you are going to use that magnetic synthesizers. Now we are going to discuss here on load or online UPS system, that is uninterruptible power supply. So online UPS system intended for protection against sag and brief interruptions can be used for the voltage regulation, provided the source voltage stays sufficiently high to keep the batteries charged. This is what the common solution for small critical computer or electronic control loads in an industrial environment that has large fluctuating loads causing the voltage to vary. So we can use a motor generator set also. So motor generator set are also used for the voltage regulation. They completely decouple the load from the electric power system, shielding the load from electrical transients. Voltage regulation is provided by the generator control, and the major drawback of the motor generator set is their response time to large load changes. So motor generator sets can take a several seconds to bring the voltage back to a required level. So this is what the another method. So where we are going to use the voltage motor generator set. If the voltage drops, then that is sensed by that sensors, and that gives the input to the motor. So where the speed of that motor that we need to increase, as we are going to increase the speed of motor, so motor and generator is coupled with each other, so the speed of generator is also going to increase. So in that case, ultimately by using excitation windings, so we can increase the voltage levels. So this is what the method, but this is what the time consuming method, so most probably this method is not used. And again the thing is of costing. So costing is more, because if you are going to if you are going to use one of the equipment, and if you want to maintain the voltage of that particular equipment, and for that again we require two different devices such as motor generator, then that becomes very costly. So that's why we are not going for such type of devices, that is motor generator set. Then next, that is called as the SVC, that is static war compensators. Again, static war compensators are of two types: the thyristor controlled reactors and thyristor controlled inductors, that we can say, otherwise TSC, that is thyristor switched capacitors. So there are two main types of static war compensators in common usage. So first one, that is thyristor controlled reactor, and second one, that is thyristor switched capacitors. Now thyristor controlled reactor that we are going to use, uh, so it employs a fixed capacitor bank to provide a leading reactive power, and a thyristor controlled inductance that is gated on the various amount to cancel all the parts of capacitance. The capacitors are frequently configured as filters to clean up the harmonic distortion caused by the thyristors. And when we are going to use the thyristor switched capacitors, the thyristor switched capacitor operates by switching multi steps of a capacitor quickly to match the load requirement as closely as possible. This is a more coarse regulation than TCR, but is often adequate. The capacitors are generally gated fully on, so there are no harmonics in the current. The switching point is controlled so that there is no switching transients. So this is what regarding static voltage compensators. Okay, so this is regarding voltage regulation and devices that we are going to use for the voltage regulation purpose. So we will stop here.